This is a four-wheel drive forklift, meant for rough terrain. When I first saw it, it had many problems. The bolts just spin. I figured it'd be easier to just buy it and then figure out what's wrong with it. In my first video, I fixed a lot of those problems, but I ignored the biggest one. Those forks are about ready to fall off. Wow, that's wiggly. The actual forks are guided on the inside of these C-channels by some rollers that roll along. That might cause some of the looseness I saw. Without forks, you can't lift. And a forklift without forks or lifting, it's like a water buffalo without water or buffalo. Might as well be a bird. So to keep this from turning into a bird and flying away, I'm going to tackle those forks. But in order to take them off, they have to go down, which means this whole vehicle has to go up. My dad has these ramps that he hasn't used in a long time, and they're only a few thousand miles away. These are going to be perfect for working on the mast on that 4x forklift. These ramps look super sturdy. They're actually bent. The more I look at them, the more I think I need to add a little material. There's quite a big hump in the middle. I think this might be working. Need to go a little more. I got some pressure on it already, so just do some tweaking. In places that don't have a cross member, I was trying to be a little creative, which seemed like it was working, until I hit the torque limit of the jack. This means we need a bigger jack. Not pretty, but it should be sturdy. I wasn't sure how far sideways you could go with the hydraulic jack, but apparently pretty far. The bottom part looks pretty good, so I sliced off a bit of angle. I'm going to set that in here and use that to lock this corner in place. I added the U-channel on the end, making a box section here, and added some angle right to the sides to effectively make that wider. So it should really resist any flex in this direction. Going up seemed fine, but then I realized my one-wheel brakes were not strong enough to hold it there. I can drive up a hill, can't stay on a hill. At least the ramps feel sturdy. Plan B, more power tools. The point of putting the channel this way is so I can drop a piece of whatever in there, and now the tire is going to hit this before going off the end. I've got blocks under all four wheels. I'm going to release it gently and see what happens. It seems to be sitting there. I'm going to add one more bit of safety holding it in place before I release all this. I put a tie down from the forklift directly to the ramp. The whole thing's tied forward and can't roll backwards. There's a bunch of stuck-on dirt and oil from years of leaks. I wanted to clean it up before I started working on it. Now I've heard the best way to clean grease off equipment is a steam cleaner. Looks like everything's going well so far. A fire. I had a few delays. It seemed like everything was finally working, and the water started to get nice and hot. We appear to have fire.
Eventually I got cleaner.
I dropped the forks all the way down. It's real easy to get to those bottom rollers, but the top ones are still buried in here. I'm going to drop these forks lower, which means I need to detach them from the lift. This chain that runs down the mast is what actually does the lifting. Now we got a lot of slack here. There's one bolt in the bottom. Apparently it's a little bit bent. We might have to tap this out of here. There we go. It should drop right out. That roller looks okay. That one, less okay. This one, also less okay. And completely missing. So out of the 4 rollers, we had 1 that was plausible. We really only have to fix 3. Well, I guess we have to fix 2 and make another one completely because it's gone. But we can do this. The pin for these rollers is basically a bolt with a nut on it and a little stub sticking off the end. A couple of them just took a little bit of cleanup. This is one of the old rollers with half a bearing stuck in it.
I found some new bearings for 20 bucks a piece on eBay.
Now a new bearing can go in this roller. Done. This one is mangled really bad. I've already turned it down to undersize. And I still have giant gouges in areas where there won't be any support. So I'm going to go even further so I can add a piece of tubing for a sleeve.
That little lathe was doing a terrible job cutting it. So we're going to fast forward in the future from here to go back in YouTube time to a previous video where I got a bigger lathe running.
That is seriously low on power. But it is spinning it. Gaining speed. Let's see if I can straighten this thing out.
Apparently the chuck on that little machine was running out of round, but this gives a perfect opportunity for a before and after.
There's the old lumpy surface. And there's the new smooth surface. That's way better. I used a piece of tubing to make a sleeve. It slid on pretty easy, but doesn't spin, so it's a pretty decent, very light press fit. I'm going to blast weld right through those holes and hold the whole thing together. Hit them with some good heat. That should hold. I did the plug welds in the tube. I also TIG welded the end. The most stress is going to be right here where it met the shoulder. I wanted to make sure that was all connected too. Now I've got to make all these lumps flat. I've got it turned down pretty well. You can still see a few marks from the weld, but just little spots. And this isn't the bearing surface. This is the part that does the spinning. And that fits. Even though the hex was pretty mangled, I was able to get a socket on it well enough to tighten down the nut. So this one is done.
Next I took some 1/2-inch steel plate and plasma cut it into circles. After that I need to machine the blanks into rollers, which in YouTube time I started in a previous video.
I'm working on the second half of that roller, which is basically the same way I showed you machining the first one, except I got to do an internal contour. I need the board to be straight and then an angle at the end to catch that corner. I set my compound at 45 degrees so I can go into the corner and then out at a 45-degree angle, and that should get me what I want. I can't really see this, but a lot of times you can tell by the sound what's happening. There's the corner. Put the bearing back in so you can see what we got. That is just what I was going for. Now I got to connect the two together and make the outside round again.
I added a really big chamfer to the inside of both parts.
Now I've got a V-groove and I can fill that with lumps of weld. I have a use for this old race. That's now a welding fixture. Some spots are more lumpy than others, but it should hold. So I'm going to pop that bearing race out and then let it cool. You can see the heat marks all the way through this thickness of metal. I think it'll stick together pretty well. Now I just need to take the lumpiness and turn it smooth. Not perfect, but it should work. Got my new roller installed. So now I have 4 good rollers with new bearings in them. This thing is ready to install. But I'm not going to install it yet, because while this is off, I have a lot more access. And there's a lot of other things right there in the front I need to fix first before this goes back on. The rod on this cylinder is bent. It curves pretty good. And the ends go to pins that go vertically, and they're held down by cotter pins. Or used to be. Someone left the cotter pin in there and went and welded this plate to both sides. So in order to remove this pin, I've got to cut those welds.
I couldn't get a complete cut because the weld went all the way into a corner. Mostly unmangled.
Got a box of goodies from the surplus center. My surplus hydraulic cylinder, just under 70 bucks. And it looks brand new, just sitting around for a while. This looks pretty close to my old cylinder. It's about a 1/4 inch bigger in diameter, but that's okay, I got a little bit of room there. The body's a little over 1 inch longer. I'm going to try to make up some of that with this back mounting. But I think it's close enough. It's got a swivel eye at the end, just like the original one. And most importantly, where that original one bent this rod, the rod on this one's a bigger diameter, so that'll be stronger. I think this one will work and possibly better. I've got the pins out of the cylinder, but I can't actually physically move it. It looks like the rod's bent so much this is jammed in there. So we're going to try using a little bit of power assist. Now this end is not the right fitting. It's just a threaded end. It's supposed to be a 1 1/8 12 thread. You can get a nut for that. Yep, that's the right one. I'll just have to attach something to this. Now this cylinder is slightly bigger than my old one, so I want to get the ends as short as possible. It's dry now. And the white paint is the excess thread. I need another swivel eye. This bent cylinder had one, so I cut it off. Now I have the nut clamped to that swivel eye. I got the ends welded on. Now I need to fill in the middle. And I don't want to get anything in these threads, so I need a filler piece. I plasma cut a lot of things out of this drop, but there's still a few chunks I can use. A few beads of weld went into the threads. I knocked off the bigger ones, and the smaller ones I'm going to call a self-locking feature. Not pretty, but I think it's sturdy, and that's all that matters. It still swivels. This end does have a swivel eye, but it's far narrower than the original cylinder. Got my pin here. I'm going to find something that's going to fit. Sure, I have something here. Too loose, too small. Right ID, way too big OD. Ooh. That looks just right. After I got this lathe going, I ordered a set of tools, and they just arrived. It was only 35 bucks, a bunch of insert cutters and things, some spare inserts. Most important for us right now, a part-off tool. You can see by the gouges there, this was grabbed with a pipe wrench to be removed. It actually is squished, much wider here, much thinner here. Apparently that's not a good idea with a cutoff tool. Yeah, learned something again. And the second one I learned, it just made myself a groove and didn't try to go all the way through. Now I got a saw guide. There, 2 oval spacers. I've got the cylinder in place, new hoses installed, and now I've got to bring this end over here.
Got to fix my pins before I install them.
I'm going to take a little tab and pop it on the top here. Need to realign it a little. There we go. Apparently the old cotter pin got welded in too. There we are. The bolts are the slate angle down, so it's actually pushing the pin down a bit. And if I need to pull this out, I got a tab to pull on.
The spacers are in, and this one is done.
In my previous video where I worked on the brakes, I really didn't know what this thing is. Now I'm not sure what that cylinder does at all. I've never seen one before, but clearly it does more than just be a T-fitting. We have a line going in from the master cylinder, and I got fluid out of the bleeder, and a line going out, and having fluid there made that wheel have brakes. I couldn't get any fluid out of this bleeder, and I never got that brake to work. So it looked like that line went to that side and something was clogged in this unit here. Then I cleaned it up and moved a bunch of hoses so I can get to this unit. I was completely wrong. The line from that bleeder ends. That side has absolutely nothing to do with that brake. So now I don't know why this wheel doesn't have brakes, and I have even less of an idea of what that thing does. It looks totally useless. It looks like the end screws, but I have no idea what this is. So I'm going to go under the assumption it's spring-loaded and point the part that's going to shoot out away from me. Let's take it apart and see what's inside. There we go. Threads always have some looseness to them, otherwise they wouldn't actually turn. So what I'm going to do here is I unscrewed it a little bit. I'm going to push in. And I can feel it is spring-loaded. I can feel it move by hand, but it's not that much pressure. There it is. I can already see we have a lot of goop in there. So if nothing else, we can give this thing a good cleaning. If we can ever get it apart. That spring takes up most of it. And there's something else inside there. It's another kind of piston. I cleaned it all up and found some stuff. On the band, it says Minnesota Automotive Inc. Right under here, it says out. I can't really get a good angle, but I can read it here. Right there it says inlet, then model, and 7704. Scraping off the cap here, this one also says inlet, and has a string of numbers down here. 03460-029. So tonight I'm going to see if I can make the internet useful. See if I can find out any info what that thing is.
The internet was actually useful. The company's changed names a few times, but they're still in business today. This is a remote actuator, and this is where things get really interesting. Normally, you press on the master cylinder and fluid goes out to your brakes. But the other line that's disconnected, if you put pressure in there, it closes off the master cylinder port, moves the piston over, and puts pressure on your brakes without you pressing the brake pedal.
I just cleaned up the unit and installed it again. For now, let's try to get that other brake working. Even without the bleeder, I'm getting no fluid there. Let's see if we have any fluid coming out of the line. I've got the rubber line off. I also loosened that connection slightly. So if that line's clogged, we'll see the fluid there. Now I'm going to go step on the brake pedal. That line is the problem. Let's see if we can find another one. Here's my line. That end looks similar. That end looks pretty close. First one in the pile. I don't remember what this is for. I'll look it up and see. But for now, we're going to try and install it. I'll worry about that when I get to the brakes on this one. That's a problem for future me. It's threading in there. That end fits. It's threading on there fine. That end fits. Think I got the air out of it. We might have all the brakes working now. This mass cylinder leaks. Most likely it's coming out from right here and I need to replace the seal. Now this cylinder is held in on a pivot way down there and this bolt right up here.
I used my other forklift to take off the mass cylinder. That way it was held up while I detached it. And as soon as I was detaching it, the forklift started running badly.
That's totally frozen up. That's my problem. The fuel is, well, not fueling.
It kept running long enough to take the cylinder off. And then as soon as I had the cylinder on the ground, it ran perfectly again.
You know, I just noticed something. I may have a bigger problem than I thought. I got the cylinder out a little bit. That is gouged up badly. That doesn't look good. Yeah, that's a lump sticking out right there. Those are big gouges. Let me see if you can hear it. There's a ton of deep grooves in this. So even if I went through all the trouble of getting that apart, repacking it and resealing it, it's going to leak through those grooves. And getting that fixed is not something I can do here and is going to be expensive. So my new course of action is to buy a drip pan and put it under where I'm going to park this thing. Problem solved.
I bought a new hose, and as soon as I tried to install it, there was a problem. Wrong size.
I went off the end down here. The end up here is much smaller. That doesn't fit. Tractor Supply had the adapter I needed in stock on the shelf. I've been surprised how handy that place is. Done. Now this cylinder goes into that pipe. When I took it out, that pipe is deeper, and they'd put a slug of steel in there to take up the extra space. So I could get this to hang in place while I get that in line. I'm going to try sliding this piece in, then sliding the bolt in to hold it up, like that. Now hopefully I can get this in just barely so this doesn't fall out. I can take the bolt out and then put this the rest of the way up. And finally, that's ready to go on.
Now it was time to line the forks back up and get them installed. In case you haven't driven a forklift before, this is the view from the driver's seat.
A little bit of visibility issues there.
A lot of time is spent getting out, checking where you are, and then making small moves to line it up. I got the other forklift going to make adjustments on that one too. My newly repaired side shifter did the final positioning, and I was able to lift it up into place.
I had to do a little bit of fiddling around. Turns out the bottom rollers were a little too far apart, but there were shims in there and I had shimmed them out. So I just took some shims out, brought them in. The floor jack and jack stands made it pretty easy. All I have to do is get this high enough to bolt this chain on. I think that'll do it. This is held on with a bolt. The one I took out was bent, so I bought a new grade 8 one to replace it. It is kind of amazing. Everything this forklift holds up is held on with one bolt. Hope this is a real grade 8, not some knockoff. While I'm talking about that, I want to point out the threads are a lot weaker than the shank of the bolt. So I made sure I got a bolt long enough, none of the weight's going to be on the threads at all. It's only going to be held on this part. It's all on that one bolt now. It's a forklift again. Both forks and lifting. Now those forks are on and secure, I want to take a peek underneath. Our transfer case is pretty obvious. There's the 4-speed transmission. Apparently that's supposed to be a T18 standard Ford unit, just with no reverse. And this is our shuttle shift box that does the forward and reverse with the clutches. I also noticed, covered in grease here, this bolt is loose. So I'm going to do something about that. Now, big question is it stripped? And is that why it's loose? It feels like it's tightened up. I'll keep an eye on that one, but for now it's fixed. I don't trust the brakes yet, so I'm going to use the old method to get this off the ramps. I'll try them out once I'm on level ground.
Now that everything's working, it's time to take it apart again.
This machine isn't charging, and I don't know if it's the alternator that's bad or the wiring. So first thing we're going to check is the wiring. There's one wire, that's it. Now there is another connection here. I'm not sure if that's supposed to be hooked up, but I know that one is. That one wire should go directly to the battery, which means I should have 12 volts on it. So let's see what we got there. Yep, we got 12 volts. In my spare parts bin, I found two alternators. This one's labeled C, then NG with a question mark. This one's labeled OK with a question mark. That one should be okay. Since I know this wire is live, the right thing to do is disconnect the battery, but that's all the way on the other side of the machine. This piece of tubing was right nearby, so I'm just going to take this live wire, shove it in the end of the tubing, and now I don't have to worry about shorting it out anywhere. Now this is not a Chevy alternator, but I don't think it's original to this machine either. The bolt was 10 millimeter. I noticed they used washer spacers to make this fit. I'm wondering if this might actually fit better. Looks like my Chevy alternator will fit nice, and I don't think I'll need that spacer in the bottom. It's in there pretty good. But what doesn't fit is this belt. That belt is way too wide for the standard Chevy pulley. This is a problem I run into every time I use a Chevy alternator on something that's actually heavy duty, or even medium duty. They use tiny, skinny little belts for cars to get better fuel mileage. Vehicles like this don't. They just want to last, which means we need a new pulley. Now I got two of them. Now this one should fit fine. It's a 1/2 inch wide pulley that fits the belt just like it's supposed to, just like it does on the water pump. This one will handle super wide belts and has a benefit of being effectively a really small diameter on this size belt. Which means this pulley will spin that alternator a lot faster for the same engine RPM. If we have trouble with the charging starting, we're going to switch to this one. New pulley's on, the belt fits well. The whole unit fits right in its mount with no spacers. The wire's on. Now I don't actually know if this is a one-wire alternator, but it might be. So I'm going to hook it up this way and see if it charges, and then add power if we need it. No charging at idle. A while ago I picked up this little connector. It's supposed to convert a Chevy alternator to a one-wire system. There's two terminals on these alternators. Number 2 is the field wire, which is what you need to power up. Number 1 is for the indicator light if it's charging. This one goes from the battery positive to the field wire, and then has a resistor in place to go to the generator charging light. So this should hotwire this alternator to work. Of course, the connector they provide doesn't actually fit. I think I got this for a couple $dollars from Speedmaster. I have not had good luck with their stuff. A lot of things have issues. Tricky to get these things to hold in a vise. Need two hands here. That's better. Let's see if that works. That's looking good. That one wire converter doesn't work well. Ran my battery dead. I need to get the alternator working, which means I need to do a little rewiring. Pulled off the hood, and a lot of the wiring just goes that way. The fuel line and the power wire that goes to the fuel pump just go through an access hole. And I have a feeling that at some point that seat is going to become a pain in the rear. Literally. So I think I'm going to bite the bullet and take off this entire section and straighten all that out when I can see everything. Luckily, every single bolt that holds this in has already been removed. It's about ready to come off. I actually can't get this cover off this gas cap. So I'll see if I can get the gas cap off. Well, that's not sturdy. I can't cut it because it just wiggles with the blade. Now we're getting somewhere. Hey, that's a data plate. Now here's that data plate. That's where the manufacturer would be. Can't really read that.
Now I know it was made by TCI because I asked in the last video.
If you've ever seen one like this, let me know.
And some of you guys recognized it.
I can read the stuff that's stamped in. There's the model H4M40G. Serial number, that matches what's stamped in the chassis. That 208N, not sure about that one. That's actually an old picture of a forklift. This is the weight rating section. We start off at 4,000 pounds. You only can lift up a certain amount, then 3,000, then 2,500 as you get higher. This 7,800 right here, that should be about right for the empty weight, so that's my guess on that number. I gave up on the steam cleaner, but I found a half-price deal on a pressure washer, so I'm going to pressure wash this thing. I think I found the problem with the coolant temperature gauge. There's the sensor. There's nothing attached to it. Let me take a look in my miscellaneous gauges box. That looks temperature-y. Oh, and a voltmeter too. Bonus. I uncoiled the capillary tube and ran it to about where it needs to go. It looks too short because that needs to go from the engine along here, up there, and then back this way. I pretty much will make it to that junction. So it looked like I needed to buy something, but then I saw that hole in the floor. Now this lever is for disconnecting the transfer case so you can flat tow this down the road. I am never going to flat tow this down the road. So I'm never going to move that lever, which means I can run right through that hole. And I think if I go straight down and straight back, I might make it. But now I have to get this gauge out. I'm sure there's a bolt under here somewhere. Can't see it. I think I feel it though. I'm working on pulling the stuff out of the dash. There is a lot of old wiring. Most of it doesn't go anywhere. I've got all sorts of ends sticking out. I have no idea what they go to. And since they're not connected, I know I don't need them to make it run. So I think I'm going to clean up a lot of this stuff. We'll just simplify a bit. Got my temperature gauge installed. So now we have mechanical temperature, mechanical oil, and 3 wires going forward. We got battery going in, then ignition and start out, and that's it. Everything else is in a pile over here. The only thing I'm going to reinstall is this fuse block. But it used to be crammed up under the dashboard. I'm going to make it a little more accessible. What I am going to add to the dashboard is a hole for the ignition switch, because there wasn't one before. There's one over there behind these levers, but I want over here where it's easier to get to. I'm still not sure what this is. The line from the master cylinder goes up to it. There's a bleeder valve, and the line to the brakes go out. That looks like a brake light switch. It almost looks like that's some kind of pressure operated switch. A fellow who saw my last video and is familiar with this manufacturer showed me a picture where the later models had an electronic switch
that connected to the brake pedal and activated a solenoid.
And that reduced the pressure on the clutches and let it slip. But this one doesn't work that way. There's no electronics whatsoever on this box.
Now that it's clean, I found a plate. It's a Funk Reverse-O-Matic, which led me to a diagram with no electronics and no pressure relief.
It looks like he uses a torque converter for slipping, which then makes me think, do you think when it's in neutral, it sends fluid pressure to that brake actuator to hit the brakes? I don't know. And I don't know what that is. So there's still mysteries to be unraveled. But in the meantime, I'm going to go with what I know and keep moving. Now I don't want this much ignition switch sticking out, but I only have the one nut to hold it in. So I made a spacer. Since I found a voltmeter in that leftover set, I'm going to add a power wire for it to the ignition terminal. Now it's ready to go in. Now my 3 wires come over here to this old system. The battery wire is stretched tight and has no fuse. The ignition on wire has broken insulation and multiple connectors. The start wire looks fine. The starter cable has the throttle linkage rubbing right against it. The alternator runs through thin gauge wire. And we already know that this little 1-wire conversion runs our battery dead. We're going to do some fixing here. This is the old alternator wire. The full power of the alternator was going through this. Found an old battery cable in my stash. It's just about the right length. It has the right terminals on the end and already has a protective layer on it with a mount. It's overkill. If I ever want to add a real big alternator to this for some reason, I'll have the wiring already in place. And it was lying around. Wiring's getting boring and I wasn't having fun, so my mind wandered a little bit. I started thinking about the shuttle shift forward reverse box thing. Now I don't actually like this. It's real jerky to use. And it occurred to me, since it has a torque converter, you don't need to put it in neutral to stop. You can leave it in gear. This is the rod that actuates the forward and reverse. This operates off these 2 pedals. You press one for forward and then you press further for more throttle. Press the other one, you get reverse and then more throttle also. And then you go back to this thing right here. I'm pressing the forward pedal and then a little bit further. Now I'm pressing the reverse pedal and a little bit further. So forward, reverse. If I take this off and get it out of that pedal system and put a real lever on it, I can just put this into gear when I want it and it'll stay there. And this whole thing would operate in a way that made a lot more sense to me. So I think we're going to do some modifying here. This project just got a little bigger. I found one of the reasons they weren't using this fuel tank. I'm just going to get this thing out of the way here. That brake's all rusty. That broke a long time ago. This is a gaping hole in my gas tank, which most people would consider a problem, but this is a problem-tunity. Because I know for a fact that directly above this circle, there's an access hole in the cover plate, and that's right next to where the shifter goes. So that is a perfect spot for my forward and reverse shifter. Found a couple pieces of scrap plate. I got a baggie of bushings left over from an old project. Those look right. I took that piece of scrap plate, popped one large hole in it. That's where my bushing goes. and then a few mounting holes. The center of this bushing is where the center of that hole is. So you just put this in place here. I know for sure any shaft sticking up here is going to go out the hole in the cover. Now I can take a shaft and pop it through this hole, and it would probably be fine, but it might wobble a little. I think I need another hole down there, all the way at the bottom. Get it back away from the chips a little bit. Don't need to see anymore. Got a pallet hole. I got a piece of tubing through that 1-inch hole in the bottom. That lever seemed awfully short. So this is going to fit over that tube. Use that hole to bolt right there. And then it moved the arm at a different angle and further out. So that is going to go over there. I didn't drill that hole in this piece because I wasn't quite sure where I wanted to put it. Once I get it mocked up, I'll run a drill through that one into this one. I made an arm that fits over my piece of tubing, and that has 2 holes in it. One for the rod that's going to operate the transmission, and this bolt that I'm going to use later. This is the original control rod. I cut it in half. Now I have to extend it to the other side. But the transmission has a large rib sticking up, right where I want to go. So I'm going to use a piece of angle, and that will give me some vertical clearance. I also put a slice in it and bent one end over, so that'll give me some horizontal clearance. Got a few self-drilling screws right into the gas tank. I think I can start attaching things. Now there's one critical thing here that I got to overcome, and that's what this bolt is going to do. I've got my forward and my backwards, but as soon as I let go, it returns to neutral. I need to make sure it stays in gear. Take a transfer punch, move it all the way to forward, make a mark, now all the way to reverse. I put a shaft collar on the bottom with a little bit of a gap. We're in neutral, forward, reverse. Wait, reverse, forward, I don't know. I'll figure it out when I drive it. Either way, I got 2 directions. Because of the angle and the pivots, this can flop around a bit. So I'm going to put an angle on the bottom of this, so if it does bump into that piece, it just rides up and over. Looks like it'll work fine. I finished off my electrical system. There's a lot less wires, it's easier to work on, and it works better. I moved the solenoid so it has 2 bolts holding it on. This is the one that was stretched taut. Now it has more length and is protected with a fuse. That goes to the ignition switch. When you turn it to on, it comes back to the old fuse block that was under the dashboard, and that powers up 3 circuits. I've got the alternator feed, goes right to the field terminal. So when the ignition's on, the alternator's on, and it doesn't drain my battery when the ignition's off. The fuel pump and the ignition. And this is all easy to get to right next to the engine. I protected the starter wire that was rubbing on the throttle linkage, and I rerouted it so it doesn't rub the throttle linkage. I added a ballast resistor and the startup wire, so now there's 2 wires going to the coil to even out the voltage. A lot of people are under the impression that a 12-volt coil gets 12 volts. That's rarely the case. Because when you're starting an engine and cranking it over, your 12-volt battery isn't putting out 12 volts anymore. It's a lot lower. Then once it's running and the alternator kicks in, you got to charge that battery, which means the voltage has to be over 12 volts. So what that dual wire setup does is when the voltage is low, it runs power straight to the coil to give it as much voltage as it can. And when the alternator is kicked on and it's running high, the resistor knocks down the voltage so it doesn't get too much. My wiring's done, my shift linkage is done. I'm almost ready to put on the seat cover, but I want to check some fluids here. Now that lump of grease right there looks like it might be a drain plug. Right now it's round. Let's see what shape it turns into. Oh, chunks coming off. Oh, it's square. Now we get to play What's in My Transmission. Let's see what we got. Oh, it's just oil. I didn't see any water or anything weird. Very black oil, so it'd probably be good to change it. It's looking good. The U-joint will be well lubricated though. I don't see any water floating up in the drain pan. We'll just let that go for a while.
On to the transfer case.
Now this feels like a drain plug, but I gotta dig before I can figure out how to actually open it, because it was just completely full of dirt. Apparently it's a 3/8 drive, so let's see what is in the transfer case. Nothing. That doesn't seem like much in the way of liquid. Just to be sure, let's make sure this isn't blocked. Nope, I can reach my screwdriver in there. It was just completely empty. Glad I checked this.
I had to do a little bit of excavating to find the fill plug.
I brought the square drive I used in the drain plug, and it looks like that's a hex. There we go. A little bit of sludge on there. Hopefully that sludge was lubricating things, because there wasn't any oil. I'm going with the 85-140 weight gear oil, because it's the thickest stuff I have. For some reason, I'm betting that transfer case leaks, and the thicker oil will leak slower. Barely goes down the funnel. That seat's worked fine, but I'm going to take it off anyway. I got another one as a freebie. This has an electric base. We'll try out that electric base tomorrow. This seat was actually welded on, so I can't unbolt it. The biggest problem with heavy equipment is everything is heavy. There we go. The old seat was welded on, but I took care of it. I retrofit power seats into a few things. So far they all work the same way. There's one power connector with thick wire. And once you power that up, all the controls function on the side here. So pretty much the only thing you have to do is figure out which one's power and which one's ground, and it's easy. And it's even easier right now, because someone already did that. One side is labeled hot, one side is labeled ground. Connections are made. I'm sure those will be fine. Let's try powering it. I saw the motor move. Let's try in. There's up. My hand here. Oh, there we're going. We moved. We're pushing power here. There we go. We're going. We're going. Hear it crunching through the rust. That's pretty comfy. Since the seat was welded in before, I think that's traditional, and I wouldn't want to break with tradition. Didn't even light the upholstery on fire. Bonus. Before I put the hood on, I'm going to pop this valve cover off. There's air bubbles coming out between the head and the block. And that's a sure indication of a leaking head gasket. But I'm not going to replace it, because it runs too well. I don't think the head gasket's blown out. What I am going to do is re-torque these. They definitely have some to go. Got about a quarter turn on that one. A couple were pretty loose, some were already at torque, but now I know they're all good. I hoard all my old pipe fittings. I got quite a pile of them. And I dug through these and made this. There's my shift linkage going through the hole where the filler cap used to be. So I can easily take this cover on and off and the linkage stays there. Then I just drop this on it. Slide a bolt through the whole thing. And I got a perfect shift lever. That works surprisingly well. It can even open and close the valve if needed. It's like a full-size fidget toy.
It's time for a test drive. Last time I tried to drive up these ramps, I had a lot of trouble going smoothly, and then I couldn't stay on them because the brakes didn't stay. Let's see if my improvements made any improvement. Everything works. Because of the four-wheel drive, this doesn't turn particularly sharply, but it drives over things really well, which gave me an idea. This thing is really stable, doesn't feel tippy at all.
Temperature looks fine. Oil pressure looks fine. Charging's fine. What we have here is a win. That works way better than it ever has. It actually works pretty decent. Now that the engine's warm, it's getting oil changed. That is the biggest drain plug I've ever seen. It's almost 3 inches across. Breaking out the fancy wrench for this one. These work great on square heads. There we go. Glad it wasn't too tight. I feel like I'm gonna get rained on here. Nope. Apparently you can't take it all the way out. It actually looks like it's the intake screen to keep the debris out of the pump. I'm glad it's clear, because with the axle right there, I don't see how to remove this. But since it is clear, we're just going to pop it back in here. Now this filter was changed recently enough, you can actually read the numbers on it still.
I cross-referenced the part number and found that came on quite a few vehicles,
including the 4-liter straight 6, the 5.2 V8, and the 5.9 V8. I've got one sitting on my shelf, gathering dust. So we're going to put this on. That looks like it. I even wrote the date on the filter so I know when I put it on. I want to mark the 4-speed pattern, because it should be a standard H pattern 4-speed from a truck, but the engine's back there. If I face backwards, then it'll be a standard pattern. So I'm going to write it down here. 1, 2, 3, and 4. I'm using a boat tank here, and I like that because I'm not going to use this that often. And I share this tank between a few vehicles. So when the vehicle sits around, the fuel doesn't. I keep using it on something else and it keeps getting fresh stuff in it. And I can just take this can to the gas station, makes my life easy. This tank can't slide forward or back or that way, but it could slide this way. We'll just wrap this around the handle, tie it on so it can't fall out completely. There. Now we're safe. Now we're to something I've been avoiding for months. When I first got this forklift, it had 2 of these rims on it, and I was told those were the original ones. These leaked, but my quick temporary fix was to pour a gallon of slime into the tire. Whole gallon. I figured it would hold air long enough to get through the video and use it a little bit. I also got this set of tires with it. These are the right size tires, but they're on regular pickup truck rims from like a 3/4 or 1 ton. So light duty stuff. This tire is noticeably taller than this tire, but I figured it was good enough for that. Pretty shortly afterwards, I fixed that problem. In a video I did about wheels, I made these rims. I've got my wheels center ready to go, and I made them to match the pair that I had that was supposed to be the original ones. And these are very heavy duty. I used 1/2-inch thick steel to make the centers. And as I mentioned in that video, a fellow who was watching my first video on this forklift felt bad for my tires, and he gave me a set of takeoffs from his skid steer for free. So I've got a good tire on a good rim. And he gave me a set of 4, so I got 2 more. So the next thing I'm supposed to do is put that tire on this rim, but I can't bring myself to do it. My temporary fix of the gallon of slime in these tires a year ago, they're still holding air. I can't bring myself to pull that tire off that rim, so I'm not going to. I also know this forklift can lift 4,000 pounds. And when I pick up 4,000 pounds, the weight on those tires is going to go through the roof. And those pickup truck rims are not going to handle it. But those back ones can. And when you pick up something heavy, the back gets lighter. So I'm going to take these tires with the light rims and put them in the back, take those heavy duty rims, put them in the front. I should be all set. I put jack stands under the fenders, which might seem like a bad idea, but what you probably can't tell from there, those fenders are thick plate steel. That's no sheet metal there. Those should hold it up fine. When I made these rims, I drilled them for the studs I was putting them on. The front ones are the next size up. A little adjustment needed. That's better. I want to point out another reason why bad tires on weak rims is a good idea on the rear. The rear axle is on a pivot, so those tires will follow the train wherever it goes. The front axle is mounted solidly to the frame and the forks. The forks and the load stay level with the front tires at all times. If a rear tire pops and goes flat, it doesn't affect the front end at all. It's just a minor inconvenience. Rear tires on a forklift are kind of like the arms on a T-Rex. They're there, but the front tires do most of the work. And the teeth, the forks. There's a surprising amount of articulation on this one. And while I'm here, I just noticed, underneath this fender is an access hole. That's way easier to get to the oil filter. Wish I'd done this sooner. Usually I get around to painting my projects, but that's not happening with this one. Where I need to use it is a remote location, and I'm gonna have to leave it unattended for weeks at a time. My good stuff up there I have locked in a building, but this won't fit in the building. So I'm gonna make sure it doesn't look nice, so no one takes an interest in it. And that's also one of the reasons I did that water pipe shift lever. Even if someone gets it running, do you think they're gonna think to grab the water valve to put it in gear? Probably not. So I'm calling this project done. It starts right up, it dries fine, it charges. I know it has oil in it, at least for now. With that extra shift lever, I think it works better than it ever did. So I'm very happy with this project. It's exactly what I need. So the next step is bringing it out there and then having some fun moving stuff around. But that's for a different video. Hope you guys are having fun too, and we'll see you next time. Let's see how this works. It's a good test for the cylinder, right?